Hi everyone and welcome to another video. In this video we're going to be looking at this device here. This is the Open Amiga Sampler. It's an 8-bit sampler that is designed to plug into the parallel port of an Amiga and enable you to sample sounds. The predominant reason for this is anyone who is doing your music, so the mod music in the Amigas, if you want to sample your own audio to be able to put into your music, or maybe a different instrument or anything like that. I mean, voice is very easy on this thing. So the idea is that you would be able to connect in standard connectors at the back here. There's a knob to adjust the gain, so that means that you can actually adjust how much this does a little bit of amplification before sending it to the analog to digital converter. After that, the whole point of this is so that you can adjust so you get maximum volume without any clipping. So you can always adjust that around. And then at the other end, we've got a DB25 plug for connecting to the Amiga's parallel port. Now this is open, hence the O. So this is all open source. This is one that I've actually made. And I've had to order, as you always do with these PCB companies, I've ordered 5 PCBs in total. So what I'm planning to do is actually make up the others and actually sell these. So if you are interested, then I will at some point, once they're all ready and I'm happy that it's all working properly, that I'll get a link probably onto Tindy and we'll see about getting it on there. So let's get this opened up so I can actually show you what's on the inside. So really super simple little PCB on this. What you've got is the cables coming from the audio. They go into the unit. They actually get combined. So although this has got the ability to take stereo in, this is only a mono device. So it will take both of those, it combines them together and then sends them through to the little preamplifier. That then sends a signal to the analog to digital converter. There are obviously a few other supplementary components on this thing as well, so just capacitors, smoothing capacitors and things like that, so just to enable to combine the audio and make sure there's no usual sort of fluctuations in the voltages, etc., all that sort of stuff. So the way this actually works, as I understand it anyway, is that when the software on the computer is, or on the Amiga rather, is requesting input, it sends a signal to the strobe pin on the parallel port. That then triggers the analog to digital to converter to take a sample, which then pumps the output onto its 8-bit bus, which then obviously connects into the Amiga and the Amiga reads it. You are limited in terms of the frequency of this, so the sample rate I think is something like about 25 kilohertz. Which is generally the amount that I'm not super au fait with this, but as I understand it, I think that's what the Paula chip can do, so the audio chip for the Amiga. So yeah, obviously it's 8-bit, so it's not CD quality. It's also only at maximum, as we were saying, about 25 kilohertz, so it's definitely nowhere near CD quality. But for the time that the Amiga originally came out, so the A1000, the A500, it was a stunning piece of kit. It's just a shame that really Amiga, or Commodore rather, didn't actually expand on that when they brought out the 32-bit machines. But that's neither here nor there. So the only other bit on here, we've got the 3 connections here which go off to a potentiometer. This is actually a logarithmic one because of the way that the hearing works. So this enables you to, let's say, go from it actually says gain of 1. My testing on this, and I can show you on the oscilloscope in a minute, actually this starts at 0 and then works all the way up to around about 10 times. So yeah, it's not exactly right in that regard, but this is a case that I made up, so maybe I'll change that, maybe I won't, maybe we'll just leave it as a foible of the unit. So yeah, the actual unit itself, I've put these bolts on the front, so we've got bolts and nuts which technically aren't needed. This was designed, so on the base here you can see there's some little nubs that stick up, which actually go into the corresponding holes of the PCB. But I actually decided to put those in, and they've got little slots they can connect the the nuts can connect into here, just so that when you're inserting and removing this thing, when you're pulling on it, you're actually pulling on a bit more plastic rather than just these two nubs at the back of it. Other than that, it's actually held together. This actually only clips together, so the whole unit is designed just so that these two plastic pieces will clip together. And the last thing, just to quickly show, there is a sticker on the bottom which just gives you a quick bit of information about the thing and some minor warnings, things like only plug it in when the Amiga is switched off. The danger of any of things like this, especially in old computers, is when you start plugging things in and out of them while they're switched on, there's a tendency for internal damage, so the chips can effectively destroy themselves internally. So yeah, just something to bear in mind with that one. So what we'll do is we'll plug this in, I'll show you it working, and then we'll grab the oscilloscope and I can show you the changes that happen with this, and I'll also show you the sampling rate for this as well, because we can pull it off the strobe pin there. The way we've got it set up at the moment, the sampler is actually plugged into the back of the Amiga at the moment. Obviously we've got the oscilloscope, and then I've got some software running on the Amiga which will, all it's doing is it's taking the input from the sampler and then showing an oscilloscope like line here, and then we've got a spectrum analyzer underneath it. It's also, the nice thing about this one is it actually outputs the audio that it's sampling as well, so it actually pipes it straight through to the output, so we can actually hear what it's actually sampling at any given moment. So now if I just turn, so the gain is currently set right down on the oscilloscope. The yellow line is the input line, so what the sampler is seeing from the phono inputs at the back, and then the blue line is what is being sent to the Amigas or to the sampler, the analog to digital converter, and then obviously into the Amiga. So as we turn this up, you can probably start to hear it come through. So if I just turn the volume up on the
amplifier,
a bit of Anders Enger Jensen. So you can see on here, currently I've got it set about halfway on the gain. So we're looking at pretty much parity, so the input is the same as the output. Nice little view there as it went down through the frequency range. So you can see as we've got, the input is basically the same as the output. What you also may notice on this is the fact that the audio is inverted, so where it's positive on the input, it's negative on the output. So that's just a quirk of the way it's the op amp is working. But as I increase the gain, you should hopefully hear the volume increase. And if we get too loud, you can see that it's all peaking out, and there's a bit of distortion in what I can hear. So let me just turn the other amplifier down. So you can see that it was just at that moment really peaking out on this. So, but you can see on here the difference between the input and the output now. So the output is definitely significantly louder than the input. So it enables you to adjust if you've got a quieter input to have the same sort of volume coming through. So that's this bit. The last bit I want to show very quickly is just the sample rate. So as I said, we can connect the oscilloscope up to the strobe pin, and in that way we can actually see what the frequency is of the sampling rate. So let me just reconfigure everything and we'll come back to that in just a moment. Here we've got the oscilloscope attached to the strobe pin, and what we can see is that the sample rate is around about 25.3 kilohertz, which is what I understood it to be, around that sort of frequency range. You can see there is quite a bit of jitter on this, which for the Amiga is fine. I don't think that really affects the audio too much. Certainly it doesn't sound too bad as it's being pumped through. So yeah, we can see that the sample rate is what we were expecting it to be. So that's it for this video. As I say, as and when I get the other ones built, I will get them up for sale if anyone would like to buy one. As a very quick aside, I am also going, they will come with the 3D printed enclosures. I am potentially going to offer the opposite way around, so you've got white case with the greyish coloured text on here. So this is just a mock-up of it, so there's no actual device in there at the moment. It's just the plug and the gain control. So yeah, probably leave that as an option, so we'll wait and see on that one. But other than that, again, thank you very much for watching, and I will see you in the next video.